Hi, I'm Bob Westby, and we're going to talk about reliable power systems. Many of our customers need reliable power systems. Maybe they have an assembly line that they simply cannot afford to let go down. Maybe they have a refrigeration unit with medicine in it. They have to keep it at a set temperature. In these cases, they need a reliable power system. But how do you create a reliable power system? That's what we're going to talk about. Let's start by looking at the sources that are coming into your power system. We want a power system that can monitor incoming sources and switch between different sources if necessary. In this particular demonstration, we have the LTC 4421. It's what we call a power path controller, and it monitors two sources. If the primary should go down, it will automatically switch to the secondary. Of course, if the primary comes back up, it'll automatically go back to the primary. Now, this 4421 can monitor two incoming sources. However, these units can be cascaded so that any number of sources can be available to your system, 2, 4, 6, whatever. That way, no matter how many sources go down, your system stays running. If you have a power system that's at all complicated, you may want a power management chip. In this particular demo, we have an LTC 2977. It's a power management chip that can monitor 8 different voltages in your power system. And it can servo those voltages in real time so that you get very accurate voltage levels. Or alternatively, you could take 4 of those lines and measure current. The 2977 has its own internal microprocessor. It uses SM bus for communications. It controls the startup sequence, the shutdown sequence of your power system. It can control the margin limits for your system, and it can do margin testing in your system. I know, sounds a little complicated, but we've made life easier. When you want to set up your system, simply connect your laptop to the LTC 2977. Use our GUI, LT Power Play, to set up and control your system. You can configure everything, set up your telemetry data. Of course, this telemetry data can also be going outside to an external microprocessor that can automatically flag for out-of-range conditions. Now, ambient conditions can be very important. What's the temperature within this system? What's the air temperature around our system? What's the temperature of these PC boards? In this particular demo, we have a Max 31827. It's a very small temperature sensor. Comes in a WLP package, and it measures about 1 millimeter by 1 1/4 millimeters. That's very small. Not only is the package small, but the bias current for it is very small also, typically in the low single-digit microamp range. And you can adjust the bias current. Simply change the frequency at which you're taking your measurements, or change the resolution at which you're taking your measurements, and you can change the bias current. Frequency could be anywhere from taking one measurement every 64 seconds to taking 8 measurements in 1 second. The resolution is anywhere from 8 bits to 12 bits. Now, because this sensor is so small and the bias current is so small, this makes an excellent candidate for populating a power system in multiple locations. In our system, we have a supercapacitor controller in the back corner, because what you don't want is a sudden power dropout. That supercapacitor is the Max 38890. It will charge up the supercapacitor at a set current level, and it has a boost mode, so that when that supercapacitor is discharging, it will set and regulate the output voltage. So we've talked about 4 techniques to help make a reliable system. We're monitoring the incoming sources, switching between different sources when necessary. We've got a power management chip to set up and control and set the telemetry data. We have a temperature sensor, which we can use in multiple locations. And we have our emergency backup power, the supercapacitor controller that can absolutely prevent any abrupt power outage. So if you'd like information about any of these techniques or any of the four products that we've just talked about, please go to our website, analog.com/power.